Hey everyone, in this video we are going to have a look at invert binary tree question on Leetcode. So what this question says is we have a root of a binary tree, we need to invert it and return its root. What do we mean by inverting a binary tree? So we have to swap the left and right child of a node, of every single node in the tree. So as you can see here, 4 have two children, 2 and 7, and in the result they are swapped. So now 7 is at the left and 2 is at the right. Similarly for 7, previously we have 6 on the left and 9 on the right, but in the result in the inverted tree there is 9 is on the left side and 6 on the right side. Let's understand it how it can be done in more detail. So this is our binary tree. Let's say we are starting from here, root node 4. It had two children, 2 and 7, and we need to swap them. So we'll just swap the left child with the right child and vice versa. So what do we mean by that? So we need to just do root dot left to root dot right, and similarly root dot right to root dot left. Just a note, before swapping, before storing root dot right in root dot left, we need to store this root dot right or root dot left value previously in a temp node. So basically how we swap two variables using a third temporary variable. Similarly to that, we'll create a temp node, let's say temp root or temp node, and we'll store root dot left in it to store the reference of root dot left, and in root dot right, instead of root dot left, we'll store this temp node. Similarly, as we do in case of swapping two variables using a third variable. Okay, so we are at root 4, and we swapped the children 7 and 2. Notice how the children nodes of 7 and 2 are still the same for now. So 6 is on the left and 9 is on the right. In case of 7, its children are in the same order, and similarly in case of 2, 1 and 3, they are in the same order. So because we have just swapped 7 and 2 only, now we need to do the same thing for their children nodes as well. We'll use recursion to do so. So let's say now we are at the root, at the left child of this 4 root node, that is 7. Now we need to swap the left and right child of node 7. So what we have done, we have swapped 9 with 6 and 6 with 9 using the same logic. Next we'll come to the node 9 and then 6, as they don't have any children. So basically what we need to do, we need to write some kind of check as well, so that if the root is none, so we'll just return none and do nothing here. So once this particular part, the left part is completed, then we'll do the same thing for the right side as well. So on the right side, we'll swap the left and right child of node 2. So we'll replace the position of 1 and 3. So now 3 will be on the right side and 1 will be, so 3 will be on the left side and 1 will be on the right side. So this will be our new tree that will return. So the space and time complexity for this code will be, so time will be O of n, where n is the total number of nodes in a binary tree, and space complexity will be O of d, because of the recursion call stack that we are using, where d is the depth, or you can say height of our binary tree. So let's see how we can do this in the code. Okay, so first initially let's just have a check that if our root is null, so we'll check if our root is equal to null, we'll just return null and do nothing. Now we need to swap the left and right child of this root. So first, as I said before swapping, before replacing root dot left child with root dot right, let's store the value in a temporary node. So we'll call it, let's say, temp node, and we'll store root dot left in it. Then in root dot left, will insert root dot right. So we are replacing the left tree with the root dot right, the whole subtree. Then same thing for the right subtree. In the root dot right, we'll store the temporary node that contains root dot left, temp node. Now we need to do the same thing for their children nodes as well. So for that, we'll call this invert tree function recursively and passing root dot left and root dot right child. So recursion will handle the swapping of left and right nodes for the children nodes root dot left and root dot right. And then at the end, we'll just return the root. So if we'll run it, yeah, it's submitted. Okay, that's it for this video. Thank you for watching.